This next topic that we will be discussing is laser parameters, and this is what we adjust on your laser. These are the most common ones found in any laser system, and as such, I expect all of you to get familiarized with them as each of these will impact your treatments. So, the first parameter which we typically adjust is the energy, or we also call it power or fluence. There are two units. Your lasers, probably designed with watts, which in simple terms, it's how fast the light travels. And we have the joules. The joules talks about the speed of light in relation to time. So there's a formula for this. It's watts times second equals joules. And joules typically refer to a specific square area of your target. Now, let's speak about the pulse. What is a pulse? It's pretty much a wave that has its on time. So you can see the flat area there is when your beam is on, and the delay is your off. Among the pulse types, we have the continuous wave or the CW. In comparison to a ammo shooting from a gun, we can compare this with a fully automatic rifle. You can see here the bullets, you keep firing, but over time you run out of ammo. In this case, there is no endpoint until you release the foot switch or your trigger. As such, it works well with cutting off your target or the tissue or the structure of the body. The next waveform we will discuss is the single shot. The single shot, we could simplify it more like a sniper. One shot per foot switch press, very controlled but very slow. What is optimal is the triple pulse. So you have three pulses going up, in between are rest or when the laser is off. Just like a semi automatic rifle, it's more accurate and safe. And here is a sample table of the different pulse modes and their risk level, starting from the continuous wave used for cutting and vaporization of tissue or body structures. It carries with the highest thermal risk. Then we have the single pulse. It's one isolated pulse each time you press the foot switch or your trigger. It's very precise, and it's also good for pigment because you need some type of a longer absorption time. The risk level is low to moderate, and for multiples, when you stack the pulses quickly, it's best for resurfacing scars and depth control. What makes this ideal is the off time in between the pulse and you being able to control the delay time, which is the pause in between the shot. Bam, bam, bam. Instead of bam, 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 bam. The importance of pulse timing and duration is very important, especially when you're treating your patients or your target. You have to know your TRT, which is your thermal relaxation time, which means it's the time when your structure cools down enough that it doesn't get injured. So the goal is to match the TRT of your target. And for your reference, here is a table. Based on this table, you should be setting your device no more than the thermal relaxation time. Because if you exceed these parameters, now you are causing damage thermally. Next is frequency. Frequency is just bunch of waves depending on your setting. So the unit is 1 hertz, which means 1 pulse or shot per second. If you have 5 hertz, expect when you're pressing on the button, 5 sub pulses is delivered, and 10 hertz, 10 pulses per second. So the way you apply frequency is you can start slow and get to the same goal without damaging them on the first application of energy. Another important parameter that's misunderstood is the spot size. Keep in mind, the larger the spot size, the deeper the penetration. Refer to the left figure here on the skin. You see it's uniformly distributing the beam, hitting lower down the dermis area, while you have a very small spot size, which is intense and creates a greater thermal damage. Great for precision and also cutting. So when you're treating, the way you use spot size is making sure that you damage the area that you only target and not overexpose it when not needed. Keep in mind the laser triangle. We consider the laser and what we've learned today, the target, its importance, on how it absorbs the energy. We need to know how this tissue interaction, the response of the tissue. Let's practice clinical common sense. Assess, assess, assess. Assess, adjust, assess, adjust. And lastly, to lessen thermal injury and to protect the top layer of the skin is we need to have an exercise cooling at all times. When that technology, especially with lasers, generate heat, we have to control the heat by cooling it down. Finally, we have this golden rule of lasers. When your clinical endpoints tell you when to stop, not the brochure. It's not the settings from YouTube. If the endpoint or your goal is achieved, stop and adjust. If the endpoint is not reached, safely increase or adjust your settings by always paying attention also to what's going on. The pulse width, all these parameters, spot size depend on the target and the chromophore physics. So bear that in mind. Now we leave this to a question and answer section. Thank you very much.